Hello and good morning to all of you, my dear students, my dear YouTube viewers. Welcome to my YouTube channel. तो आज हम बात करेंगे कनकेव मिरर के बारे में। ओके, तो जो कनकेव मिरर में अगर हमारा ऑब्जेक्ट इन्फिनिटी पे रहेगा तो उसका इमेज कहाँ पर होगा, अगर हमारा जो कि ऑब्जेक्ट सेंटर ऑफ कर्वेचर पे रहेगा तो उसका इमेज कहाँ पर होगा। वो ऐसे ही बहुत सारे पोजीशन है जहाँ पर हम ऑब्जेक्ट को रखेंगे और उसके बाद हम देखेंगे इमेज कहाँ पर हो रहा है, इमेज की डिटेल्स, ठीक है, और यहाँ पर मैग्नीफिकेशन हो रहा है या फिर नहीं हो रहा है। तो चलिए दोस्तों शुरू करते हैं। तो आगे बढ़ने से पहले मैं एक बात बताना चाहता हूँ, अगर मेरे चैनल को अभी तक सब्सक्राइब नहीं किया तो प्लीज़ सब्सक्राइब कर दीजिए, साथ ही साथ बेल आइकन को हिट कर दीजिए, तब जब कभी मेरा नया वीडियो आएगा तो आपके पास बहुत जल्द आ जाएगा नोटिफिकेशन। ठीक है मेरे दोस्तों, तो चलिए शुरू करते हैं। तो देखिए यहाँ पर जो कॉनकेव मिरर है उसका पोजीशन है अभी कहाँ पर, अभी है इन्फिनिटी पर। अगर हम इसको इन्फिनिटी पे रखेंगे तो उसका लोकेशन जो कि आएगा इमेज का वो कहाँ पर होगा, एट फोकल पॉइंट और द फोकस। ओके, एंड द इमेज will be the real image and its orientation will be the inverted. Okay, and the magnification is lesser than the size of the object. Okay, the magnification will be the less than 1, that means it is lesser than the size of the object. Okay, so the image size is lesser than the size of the object. After that, when the object is placed in between center of curvature and your infinity, that means the point is like that. Okay, suppose this is a your concave mirror. Okay, this is a concave mirror like this, and this is the center of curvature C, and this is the infinity line. Okay, just mistake. Okay, this is the center, this is the focal point. Okay, then when the object is placed in between the your infinity and your center of curvature, then what happens, then your image will be between focus and center of curvature, that means the image will be here. Okay, image will be here, got it, image will be at that point. So now what is the type of image it is. Okay, what is the details of image it is, that means how the image is produced, what is the property of the image. The image will be your real image and inverted. It is also your lesser than 1, that means what, lesser than 1 means it is less magnified. Okay, that means the size of the image is lesser than the size of the object. Next, when we place the object at the C, that means the center of curvature, then the image will be at the center of curvature, but it is a real image but it is inverted. Okay, and your magnification will be equal to the object. Okay, that means that is equals to 1. Okay, that means the size of the object and the size of the image will be remaining same, got it. After that, when it is placed in between focal point and center of curvature, that means between C and F, so the image will be produced at the C and infinity. Okay, so image will be produced at the another hand, and it is also real, it is also inverted, it is greater than your 1, that means the magnified image. Okay, and when it is placed at the focal point or the focus, then image will be produced at the infinity, and it is also real and it is also inverted, and the magnification is very greater than 1, that means it is very magnified image. And when the your image object is placed in between focal point and the pole. Okay, got it. So the the object is produced at the behind of the mirror. Okay, and in this only case the virtual image is produced. So my dear friends, when the virtual image is produced in the concave mirror, when the object is placed in between focal point and pole, then the virtual image is produced, and the image is produced behind the mirror, and it is the erect image. Okay, and it is a magnified image also, got it. So very important. So hope you will understand, my dear friends. Okay, So my dear friends, let's come to the another kind of mirror, that is the convex one. Okay, in case of the convex mirror, what is happening? The position of the object is at the infinity. Got it? So when the mirror is placed at the infinity distance between the far away from a object, then the image is produced at the in front of the mirror. Very very important, it is image is produced at the in front of the mirror. Okay, and how the image is produced? Image is produced at the focal point, and it is virtual image, erect image, and it is very very lesser than 1. That means it is a less magnified image, very very less magnified image, we can say. Okay, and it is present in between pole and the focus. Okay, got it? So this is the kind of convex mirror. Okay, hope you will understand, my dear friend. Okay, my dear friend, come to the next point, that is the law of refraction. So what is law of refraction? There are only two laws of refraction, like the laws of reflection. Got it? So there is some only difference in that. We have now going to discuss about that. Okay, so what is that, the law of refraction? The first law states that the incident ray, the normal to the any refracting surface at the point of incidence, and the refracted ray all lies in the same plane, called the same plane of incidence or the plane of refraction. So my dear friends, the incident ray, what is that incident ray? Suppose you have observed here the torch is emitting some rays, so it is called as it is incident ray. Got it? The normal means the perpendicular line, okay, present before the refracting surface, that is known as your normal. Got it? That means it is always perpendicular to the surface of refraction, my dear friends. Got it? All these two things. Okay, and the point of incidence. Got it? The refracted ray all lies in the same plane, my dear friends. It is like the laws of reflection. Okay, hope you will understand. The next law is sin I divided by sin r is equals to constant. That means the ratio between the angle of sine angle of incidence and the ratio between the and the sine of angle of refraction is a constant. Okay, so always it is a constant term. Got it? And it is also known as your Snell's law. Why it is known as your Snell's law? Because the scientist Snell have discovered it. Okay, so according to him name, it is also known as your Snell's law. So my dear friends, hope you will understand. So here sin I by sin r equals to n2 by n1. Okay, what is n2? N2 is the your medium. Okay, medium 2 to which the rays are refracted. And n1, what is n1? N1 is the medium from which rays are going to be refracted. Got it? And v is the velocity of the medium 1 and v2 is the velocity of the medium 2. Okay, lambda 1 is the wavelength of the medium 1 and lambda 2 is the medium wavelength of the medium 2. Okay, so these are all about the Snell's law. Hope you will understand. So my dear friends, come to the next point, critical angle and total internal reflection. So my dear friends, what is a critical angle? So critical angle is the angle made in a denser medium for which the angle of refraction is in the rarer medium is 90 degree. Okay, so what is critical angle? It is an angle made of in a denser medium for which angle of refraction in rarer medium is 90 degree. Okay, when the angle of refraction will be 90 degree, then we can say it is a critical angle. Okay, got it, my dear friends? So what are the conditions for the total internal reflection? Okay, so when the critical angle is formed when the rays of light going from the denser medium to the rarer medium. Okay, when the angle of refraction is 90 degree, then we can say the angle is critical angle. Okay, and when the critical angle is happening, okay, when the critical angle is happening, total internal reflection will be occur. Okay, when occur? Now when the angle of incidence will be the greater than critical angle. My dear friend, got it? What is critical angle? First one thing, when the angle of incidence is greater than critical angle, we can say total internal reflection will occurs. Okay, so what are the condition? Let's read it. Okay, लाइट इन इज इंसिडेंट ऑन द इंटरफेस फ्रॉम द डेंसर मीडियम. तो यहाँ पर क्या हो रहा है, यहाँ पर जो हमारा लाइट है वो कहाँ से कहाँ जा रहा है, वहाँ यहाँ वो डेंसर मीडियम से लाइटर मीडियम और रेयरर मीडियम को जा रहा है. ठीक है, नेक्स्ट पॉइंट में हमारा क्या बताया गया है, एंगल ऑफ इंसिडेंस शुड बी ग्रेटर देन द क्रिटिकल एंगल. ओके, व्हेन द एंगल ऑफ इंसिडेंस इज ग्रेटर देन द क्रिटिकल एंगल, देन वी कैन से द total internal reflection will occur. Okay, so it's very simpler thing. When the angle of incidence is greater than 90 degree, then we can say total internal reflection will occur. Okay, so when I is greater than C, then we can say the total internal reflection occurs. Okay, what is the benefit of the total internal reflection? So we have already known it in our daily lives, in our different healthy materials. Okay, in our different hospitals. Okay, so how? This is a very simple one. You have seen about the endoscopy. Okay, how endoscopy occurs? What is the basic principle in it? It is the total internal reflection occurs in the endoscopy. Okay, hope you will understand.